Series connections are connections that are connected from end to end, meaning that the current flow cannot be divided between two components and it has to flow equally through all of the components. Now, this may sound quite confusing, but don't worry, I'm going to show you a few practical examples where we're going to be using batteries as well as resistors. Series connections are connections that are connected from end to end, meaning that the current flow cannot be divided between two components and it has to flow equally through all of the components. Now, this may sound quite confusing, but don't worry, I'm going to show you a few practical examples where we're going to be using batteries as well as resistors. So first, let's start off by having a look at batteries. Now, I've already written down the formula right here. So this is going to be the formula that we're going to be working with in series connections. Now, something to note about these batteries, these are normal AA batteries that you find in remotes and all sorts of electronic devices around your home. You'll notice that these batteries has a volt of 1.5 volts. And we can go ahead and check this out by having a look at it with the multimeter. Let's use the multimeter right here. We can see 1.578 volts. And I'm going to write this down and I'm going to show you later why I'm doing that. 1.58 volts. And our other battery has a voltage of 1.6 volts. So 1.6. So what does it mean when we connect these batteries in a series connection? Now, series, as I've mentioned earlier, is an end-to-end connection where current cannot be divided between two paths. It has to follow the singular path. So this is going to be a series connection. As you can see here, we have a positive side of our battery and we have a negative side. Same with our other battery, where this little bump right here is our positive side and our flat spot side is going to be our negative side. So what happens right here is we connect our positive end to our negative end of our other battery. Now, what's this going to mean? This is going to mean our voltage is going to increase and our capacity of the batteries are going to remain the same. So let's have a look at this in practice. So when we connect these batteries in series, we should get a voltage V1 plus V2. That's going to give us our total voltage. Now V1, as we've mentioned right here, is 1.578 volts and V2 is going to be 1.6 volts plus 1.0 volts, and that's going to give us our total voltage. So I am no calculator, so I'm just going to go ahead and grab my calculator right here, and we can take this and just type it in calculator, and that's going to be 3.178 volts. 0.178 volts. And this is going to be our expected voltage value when we connect these batteries in series. Now, this can be quite difficult to hold these together and to actually measure them. So I'm going to go ahead and I'm going to add them to two of these holders that I have right here. So usually the spring side receives our flat side, which is indicated by a black wire, and this is going to be our negative side of our battery. Then I can do the same with our other holder right here. So as I've mentioned, let's have a look at a diagram on how we're going to be doing this. If I have my first battery right here, our little bump right there, we're going to be connecting our other battery like this, meaning that our negative of the one battery sits here, positive, negative, positive. Now this is known as a floating voltage point. We have combined these two in creating a floating voltage point, meaning it can be either positive or negative, and I'm going to show you why just now. But our total voltage, this is going to be our new negative, and this is going to be our new positive. Between these two terminals, we should get 3.178 volts. And we're going to check that out now and see if that is actually true. Okay. Over here, we're going to take one red wire, which indicates positive, and we're going to connect it to a negative of the other battery, which is going to be the black wire. Don't worry, you won't short anything out, nothing will explode. When we have these two connected, we can go ahead and measure the voltage across these two wires, which is going to be our new positive and negative points. When I take my negative path, my more positive, 3.179. which is very close to what we actually were looking to calculate right here. So why is this useful to know? So you'll find that in most of your electronic devices in your home, you'll find that you are at least using two of these batteries, and they are connected in series, You generally find them in holders like these. Think of your TV remote, which uses a similar holder to this to connect your batteries in series, because most electronics can't operate on 1.5 volts. It needs at least 3 volts to operate. And that's why series connections are very important in your modern life, because these cells can only go up to 1.5 volt. Those are the characteristics of these batteries. And we need to increase the voltage for certain applications. Similarly, you get a bigger one like this as well, which goes up to 6 volts. This is going to be 4 batteries connected in series. Now 1.5, 1.5, 1.5, 1.5 is going to give you around 6 volts, and this is going to give life to our 5 volt devices. You'll find a lot of electronic cars and toys are going to have these battery holders in there, because motors generally require around 5 volts to operate, and especially the remote control devices like electronic remote control cars and so on. So that's it for series connections on our batteries. Next, we're going to be having a look at series connections with resistors. So over here, I have 2 resistors positioned on here. Well, actually 3, because this is a combination of 2 resistors that I've connected in series. So do note that they are connected end to end, whereas we still have our new points. Now, there is nothing like a positive side or negative side on a resistor, but you can still connect them in series. As you can see here, it's still connected end to end, so the current has to flow through the resistor to the other end. And the resistor value, when we use resistors, it's going to be very similar to the batteries, whereas our R total, which is going to be our total amount of resistance, is going to be equal to R1 plus R2 plus R3. And it depends how many resistors you have connected in series. But for a basic example, I'm just going to be using 1 and 2. Let's take the multimeter and have a look at what resistance value we have right here. So we're going to see we're at around 328 ohms. Telling me this should be a 330 ohm resistor. Oop, there we go. Now, if we use this formula right here, we should expect to get a 660 ohm resistance when 2 of these are connected in series. So let's have a look at the distance right here. And there we go, 654. Remember, there is a tolerance with resistors, so it's not exactly the amount of ohms that it says, but it's close enough. So as you saw there, we got very close to 660 ohms, meaning that this is just 330 ohms plus 330 ohms, and that's going to give us 660 ohms. Very easy. So that is series connections. You can also connect loads of things in series, but I'm not going to go through everything. Things like lights can connect in series. So when you do connect lights in series, I'm not going to look at an example now, but you'll find that connecting, the more lights you connect, the more volts you actually require to drive those lights. So let's say we have a 1.5 volt light. If we add another light like this, series with this light, then we'll find that we're going to need 3 volts to drive these 2 lights in maximum brightness. So those are series connections. I really hope you guys did enjoy. Next, we're going to be having a look at parallel connections. Thank you so much for watching, guys. I really hope you did enjoy. I hope you understand series connections a bit better. Please remember to like and subscribe, and I'll see you guys on our next video.